Okay, good morning, welcome. Okay, so we're going to look today at optimization problems a little bit. So for the major this week, it will only involve a square or a rectangle or a cuboid of some kind. The optimization problem won't have the more advanced geometry. So with an optimization problem, you usually have to start off by finding the formula which you're going to optimize. So in this case, we're asked to find the area of this rectangular pen. So we can say the area is equal to x times y. We call this the principal formula, but usually there's going to be some kind of a constraint formula that we use to replace one of the two variables. We need to get this down into a formula which is just in terms of x. So if we look in the introductory sentence, which is very important for this question, we see that the length here is going to be 48. That means that 2x plus y has to equal 48. And then we can rearrange this constraint formula to give us an expression for y in terms of x. So we can come back to the area now, take y and replace it with that expression. This would be enough to get you full points on part A. I would generally leave it like that in part A, so you get the full points there. But then in part B, we need to differentiate it. So here at this point, we need to expand the bracket. And the reason we would finish it there at point A is in case you expand it wrong, you're not going to lose your point in part A. So this would give us 48x minus 2x squared. Then we need to differentiate A with respect to x. What would the derivative of this be? 48 minus 4x. You guys sound great. So this is the derivative. Lastly, we need to find the value of x, which maximizes the area. Now, the formula we're looking at there, this is the formula for area. We're given this formula, or we've calculated this formula, and it's going to, just working that out, it's going to look something like this. It's going to go through 0 here. It's going to go through 24 there.
You can just graph it.
We can just graph it on the calculator, but we should graph it correctly. Obviously, it's going to look like this, going through 24. Like that. So it should look like this. Obviously, the domain of this one is going to sort of stop here and stop here, and the other two bits need to be removed. But what we're interested in finding out is the value that maximizes it. And that's going to occur here, where the tangent to the curve is going to look like this. What would be the gradient of the tangent at this particular point?
0.
This is key. This is key. This is key to optimization. Maxima and minima occur when the derivative is equal to 0.
Sorry for question. B is the final answer of 48 minus 4x.
Hold on, let me just finish writing this. So the key to this topic is this sentence. So any question about derivatives, let's say you get a long 18-point question and you're like, to this. Often you might get stuck in this introductory part. And they often structure some of these longer questions with a show that the formula is this. And the purpose is now is if you get stuck with the geometry part here at the beginning, you can still pick up the formula that just said that you're supposed to show and then continue the rest. Any question about maximum and minimum, find the function if it's there, differentiate it, set it equal to 0, and find the roots. Even if you don't have a clue of what you're doing, that will get you half the points on this type of a question. But if you have no idea what you're doing, take the formula, differentiate it, set it to 0. If they give you the derivative, set it to 0, find the roots. And that might be what they're asking for. So
what we need to do is find the value of x when the area has a maximum. So for C, our first point comes when we say 48 minus 4x is equal to 0. And then we need to solve that one. X is equal to 12. This question is done at this point. This is a very short question. It's designed for paper 1. Just a little. This is the easiest, shortest sort of maximum optimization problem you can get.
Yeah, I have a question. After you make the equation 2x plus y equals 48, then why does it become like x parentheses 48 minus 2x? Like in a case, like you have that.
So we've got the formula which is x times y.
Yeah.
And like I said, this is the principal formula. We can't differentiate this. We have to find somewhere in the question a constraint formula. Now, in this case, we're told that the farmer takes a rectangular pen using 48 meters of fencing. So it means that fencing that he's putting up is 48 meters long. And we can see that's going to be x plus y plus x, or 2x plus y would be 48. Rearranging that means y is equal to 48 minus 2x, because obviously if you have a set amount of fencing, the bigger that we make the x, the smaller we're going to be making the y.
But then why do you put like an x in here?
Because you're solving for x. You want to get
So I'm replacing y, which is here, with y, which is here, which is the same as this expression there. So, and all of the questions involve this step. So they all involve this step. You take your y, you take out your constraint formula, you insert it to replace for y.
Oh, okay, good.
Okay? All right.
That is your basic question.